Hi there. You may have noticed in my other videos on section 1.2 that I kind of leapfrogged over something. I was really excited to get to combining functions apparently. So jumped over part of the notes and I wanted to go back and actually talk about that. It is important. So we've talked about how functions can come to us via a formula, and we've done plenty with that at this point. We've also seen some examples where a function comes to us via a table of values. Another important way that a function can be presented to us is via a graph, sort of the geometric approach as opposed to like an algebraic or a numerical approach. So I wanted to talk a bit about functions and graphs here. You'll notice my screen is filled up with a graphing utility that's available for free online called Desmos. We'll talk more about how Desmos works when we discuss section 1.4 later on in the course. So for now, I'm just using it so I can get some pretty pictures. So a function come to us via a graph. Let's take a look here. So one of the examples we've got is y equals 4x squared. Okay, so that generates this nice little curve right here, right? Okay, so this is in fact a graph of y as a function of x. So I wanted to come back, the notes mention this, and there's sort of an important test, just like we saw that all tables of values aren't automatically, giving us a function of x. We saw that example where we had two x values pointing, or an x value pointing to two different y values. The same thing can occur with a graph, and as it turns out, interpreting that each x can only point to one y thing in a graphical sense, you end up getting this thing that our notes file refers to as the vertical line test, because that basically ends up sort of acting as a check on whether or not you have an x assigned to two y's. So what I'm going to do here is use my Desmos tool and generate myself a vertical line. So don't worry too much about this. You'll see now the vertical axis is now highlighted blue because it's my vertical line that I'm working with. You'll notice this line only crosses the graph corresponding to that y equals 4x formula from the notes file at that one spot right there, what we call the origin. And no matter where I move it around, so let's try moving it there. So you'll notice still only one intersection. But what if I try to go the other way? What if I look back in that direction? We've still only got one crossing. The point is conveniently kind of called out, right? You can see the dot right there. And we can do the same thing, if I jump out to 2. If I go out as far as I did right there to an x-coordinate of 2, you can't see, but we can assume the graph continues as we're seeing it. So yeah, eventually we'll get a crossing, but we're only going to get that one crossing. So just to, well, that's not quite enough. Let's try one. There we go. Yeah, 1.5 catches us right there up at the top of the graph. So it's really close, but if you were to zoom in, you really only do have that one crossing. So this graph passes the vertical line test, and as such, it is giving us a graph that represents y as a function of x. So each x really is only connected to one y value. All right, let's take a look at this other example that appears in the notes now. So we have y squared equals 2x. And I forgot to delete my original line, but you can kind of already see the problem, right? So the vertical line test says our vertical line can only intersect the graph one time at most. If it ever, anywhere, intersects the graph more than once, then the graph is not giving us y as a function of x. And again, I could move this thing around. I moved it back to 1. Technically, if we move it back and just consider the vertical axis, it only touches in that one spot. But remember, the way the vertical line test reads, it's not that you can find a place where it only crosses once. It's that no line can ever cross the graph more than a single time. So again, if we move this guy further out, you can see there's a whole bunch of places you can sort of mentally imagine yourself taking this line and sliding it around, and you're going to keep getting two intersections with this thing anywhere except right at that spot at the origin. So this particular formula is not a graph of y as a function of x. So that will bring to a close what I wanted to talk about in section 1.2 on functions. So we'll take a look at section 1.3, as I mentioned in another video, a very specific type of function. We'll see that next time.